Hi everyone, in this video we will show how to find the domain of different types of functions. First, let us find the domain of a constant function. For example, if x equal 3, this is a constant function. We can graph the constant function. For example, this is 3, 2, 1, like a horizontal line. So, as we see here, the domain of a constant function is from minus infinity to infinity, or we can represent it as all real number. Okay? Now, for a linear function, if x is equal to 2x plus 1, for example, we have this linear function. We can represent this function as line, like this, or sometimes we can represent like this, depending on the slope of this function. Okay? Now, for any linear function, we can see that the domain is always also domain is from minus infinity or to infinity, or we can represent it as all real number. Okay? Now, also we can find the domain for quadratic function. For example, 2x plus 1, always we know that the quadratic function, the graph of the quadratic function is like this, if it open up, or we can present the quadratic function open down, like this. Okay? In each cases, we see that the domain of this function from minus infinity to infinity. Okay? So, the domain of the quadratic function is from minus infinity to infinity. What about cubic function? If x is equal to x cubed, for example, plus 1, we see that the graph of this function like this, for example, or if it negative, we can present it like this. Okay? So, as we see here, the domain is also from minus infinity to infinity, from minus infinity to infinity. So, the domain of the quadratic function also from minus infinity to infinity, or we can see that it is the real number. If we have this type of function, if x is equal to 3 over x. As you see here, what we want to do is making x equal 0. Because if x equals 0, the function is undefined. So, x not equal to 0 is all the domain except 0. So, the domain is equal all real number except what? 0. Or you can represent it like this, from minus infinity to 0, union from 0 to infinity. Okay? Now, this is the domain of the quotient function. Let us give another example. For example, if x is equal 3 over x plus 3. What is the domain for this function? We take the denominator x plus 3, this denominator must be not equal to 0. So, x plus 3 not equal to 0, that is x not equal to minus 3. So, the domain in this function is all real number except minus 3. For example, if we have this function gx is equal to 3x minus 1 over x squared plus 7x plus 10. Okay, what we want to do now is just making the denominator is equal to 0. X squared plus 7x plus 10 not equal to 0. And just we need to factor this to see what are the two numbers. If we add, give 7. If we multiply, give 10. That is very easy, 2 and 5. So, we take x plus 5 not equal to 0, that is x not equal to minus 5, and x plus 2 not equal to 0, that is x not equal to minus 2. Okay? So, what are the domain in this function? The domain is all real number except minus 5, and minus 2. Okay? For this type of function, we see that x squared plus 4 not equal to 0. And x squared plus 4 is always not equal to 0 because x squared is always positive and 4 is always positive, and always if we add this, it is not equal to 0. Or if you find that x squared impossible to be negative because x squared is always positive. Or if you want to find it in another way, you can find a1, b is equal to 0, c is equal to 4, and you can find the discriminant of this function d is equal b squared minus 4ac, and b squared is 0 minus 4 by 1 by c4 is equal to minus 16. Minus 16 is negative, so the discriminant is negative. If we find the discriminant is negative, then there's no solutions for this quadratic expression. For this, so we cannot find any solution that making this quadratic expression 0. So here the domain is all real number. Okay? Now for the radical function, if x is equal to square root of x, we can find that the radical function is like this. This is the square root of x. And always the any number inside this radical, if it even radical, the power of this radical is even, then always we take x greater than or equal to 0. Okay? So the domain of this function from 0 to infinity. Any number from 0 and 0 itself, it is in the domain of this function, since square root of 0 is equal to 0. Okay? What about this function? Gx is equal square root of x minus 2. Same thing. We take this expression inside the radical x minus 2 greater than or equal to 0. Okay? Then we can solve this by x greater than or equal to 2. So the domain of this function is from 2 to infinity. What about if inside the radical function there is a quadratic function or any function? What we have to do? We need to factor this function and see where is the function is greater than or equal to 0. X squared minus 4, if we factor this, it is x minus 2 by x plus 2. That is, for the quadratic function, we can use this rule for finding the sign for x squared minus 4. Same, different, same. Same sign of x squared, it is positive. Different sign of x squared, negative. And same sign for x squared, it is positive. You can check this to see the rule. For example, 0. 0 squared 0 minus 4 is equal to minus 4. This is negative. Okay? Always use this rule for the quadratic function. Where is the function is greater than or equal to 0? We find that from minus infinity to minus 2, it is greater than or equal to 0. And from 2 to infinity, it is greater than or equal to 0. Okay, so the domain of this function is from minus infinity to minus 2, union from 2 to infinity. If a minus 1, for example, is equal to minus 1 plus 1 under the cubic root, it is cubic root of 0, and this is just only 0. If 0 is equal to 0 plus 1, that is 1, and cubic root of 1 is equal to 1. If minus 9 is equal to cubic root of minus 9 plus 1, and this is cubic root of minus 8, and this is just only minus 2. So the domain of any odd power of radical is always all real number, like the polynomial. What about if even radical in the denominator? if even number in the denominator, we just take x plus 5 is greater, just only greater, not greater or equal. So just only greater, not greater or equal. So x greater than minus 5. So the domain here is just only minus 5 to infinity. Note that here it is open interval, open interval, not closed like the radical, because it is in the denominator. Okay? In this function, we see that we have a radical function, an even radical function in the numerator, and we have a quadratic function in the denominator. We take every one alone. This is x minus 2 greater than or equal to 0 because the radical, and x greater than or equal to 2. Okay? Now, what about x squared minus 2x? We have to factor this. X by x minus 2 not equal to 0. That means x not equal to 0, and at the same time x not equal to 2. Now, we can represent this in the number line to make it easy to find the domain. Now, look here, this is 0, this is 2, okay? And we always take 0 outside the domain and 2 outside the domain, since it is in the denominator, okay? And look here, we have x greater than or equal to 2. So all the number greater than or equal to 2 is the domain. What is the intersection of the domain of numerator and the domain of the denominator? It is x greater than 2. Okay? X greater than 2, it is the only number allowed in this function to be the domain. So the domain of this function is just only from 2 to infinity. Note that 2 is open interval. Okay? Look to this function. We can find a radical in numerator and radical in denominator. Now we can take every one alone and find the intersection between the domain of the numerator and the domain of the denominator. Okay? Now, since the numerator is radical, we take x plus 1 greater than or equal to 0. That means x greater than or equal to minus 1. Okay, if we take 1 to the other side. What about this? For this, we find x squared minus 9 greater, just only greater, because radical in the denominator. Okay, how we can factor this? We discussed this before. We just take the factor for this is x minus 3 by x plus 3 greater than 0. So this is minus 3, this is 3. Okay? Now we use the rule. This is same sign, different sign, same sign. For what? For x squared. Same sign for x squared, positive, different sign, negative, same sign, positive. So from minus infinity to minus 3, and minus 3 itself is undefined, and from 3 to infinity, 3 itself is undefined. Okay, this is 0. And what about the numerator? For the domain of the numerator, it is from minus 1 to infinity. Okay, now what we need? We need the intersection between the numerator and the denominator. The intersection is from 3 to infinity, as we can see here. 3 itself is undefined, so the domain is just only from 3 to infinity.